Let's see this question. We're given two functions. So f is defined from 2 space to 3 space. Right? So basically, the function f sends a vector in dimension 2 to be a vector in 3-dimensional world. And g is a function sends a 3-dimensional vector to a vector in 2 dimension. So we want to find the derivative of f composed with g. So we can think this way. So g goes from 3 space to 2 space. And f goes from 2 space to 3 space. So f composed g, so this is the f. F composed with g is from 3 space to 3 space. Then the derivative of f composed with g should be 3 by 3 vector. So we can go 2 ways to find the derivative of this composition of 2 functions. So one way is to use, so let's do the first one. This one, we can just calculate f composed with g. Right? G takes u, v, w as input. As f takes, what's the g? How's g function defined? G function defined as this. U times v, the v times e to the w. And then in function, f takes x, y. So this is the x, this is the y. How is f defined? F is defined as x times y, uv times v e to the w. So we get a uv squared e to the w. And the second component is x plus y. So uv plus v e to the w. The component is x minus y, uv minus v e to the w. So we just find f composed with g. Now we can take derivative of this. To derivative of this, we think, okay, we have maybe call this h. So 3 components, we have h1, h2, h3. So we need to take partial derivatives with each. So remember, derivative is 3 by 3, not vector matrix. 3 by 3 matrix. Right? So we have the first row will be partial derivatives in terms of u, v, w for h1 for this first component, right? We can think as the first component as a function of u, v, w, right? So you can think there's a gradient of this function. So partial h1, partial v, partial u, that's a v squared e to the w. We'll take derivative in terms of v, but 2 u v e to the w. We'll take partial derivatives in one direction, we hold other directions as constant. Then in w direction, just itself u v squared e to the w. That's from the first component. The second component, when we take a derivative with u, we get a v, because this is a constant. So in u direction, it becomes 0. So we get a v. In v direction, we get u plus e to the w. So u plus e to the w in v direction. In w direction, we get a v e to the w because uv in w direction is constant. V e to the w. Third component, in terms of u, we get v again. In terms of v, we get a u minus e to the w. In w direction, we get a negative v e to the w. Right, now we just have to calculate. So this is derivative of f composed with g. Then we want to evaluate. We want to evaluate with the given condition 1, -1, and 0. Basically, u equals 1 because g is defined as uvw. So the second one is vw. So we just plug in the values of uvw. Well, V is negative 1 squared positive 1. And e to the w is 0, e to the 0 power is 1, so we get a 1. U is 1, V is negative 1, W is 0, so we get a negative 2. U positive 1, V squared, negative 1 squared become positive 1, so we get a positive 1. V negative 1, U, U is 1, e to the W, e to the 0 is 1, so we get a positive 2. V negative 1, e to the 0, positive 1, get negative 1. V again, negative 1. U minus e to the W, U is positive 1, e to the 0, positive 1, 1 minus 1, get 0. V is negative 1, negative 1 become positive 1 times e to the 0, positive 1, get positive 1. And that's the answer, that's it. So this would be first method. Now let's try the second method. Second method, we use the property of derivative of composition functions, which equals to the product of the derivative of f takes g as input, then multiply the derivative of g. Well, each one is a matrix, so we'll end up with a matrix multiplication. Okay, let's try the second one. Let's try the second method. Second method, we have to calculate the derivative, the rate of change of f in terms of each variable, and the rate of change of g in terms of every variable, then multiply the two matrices. Okay, let's do that. So f goes from 2 space to 3 space. So df should be 3 by 2 matrix. And let's see df x 3 by 2 matrix. So two columns, 3 rows. So first, so we think the first component as f1, second component as f2, third component as f3. Basically, each row, see, this is a gradient f1, this is a gradient f2, this is a gradient f3, right? So each component is a function in terms of x, y, and also is a real value function. So the first component in terms of x, the rate of change is as y. In terms of y, the rate of change is x. Second component rate of change in terms of x is 1, in terms of y is 1. Third component in terms of x is 1, in terms of y is negative 1. So that's our df, right? So where do we get a value of x and y? Here's this. Because we're given the input of g, right? We know the first one is u, second one is v, this is a w. Remember when f takes g as input, so f takes this as input. F takes, so this is our x value, this is our y value. So that means when u is 1, v is negative 1, x is negative 1. So we have x is a negative 1 because u is positive 1, v is negative 1. Okay, negative 1. What about y? Y is v times e to the w. E to the w, e to the 0 is 1. V is also negative 1. So this is also negative 1. So, okay. So right. So basically this is df. X is negative 1, y is negative 1. So we evaluate now. Let's do gg. Right, g takes u, v, w as the input. Well, G goes from 3 space to 3 space. So we have a 3 by 3 matrix. So G, oh no, G goes from 3 space to 2 space. So we have 2 by 3 matrix. We have 2 by 3 matrix. F composed with G goes from 3 space to 3 space. So we only have 2 rows, 3 columns. Right? So think this. So we're taking derivative with G. So call this first component, call this the second component. So we need to do the first component partial with the U. We see that's a V. Partial with a V, that's a U. Partial with a W, W is not there, so 0. Second component, partial G, partial U, 0. So the U is not there. With V, get E to the W. With W, get V, E to the W. Then we evaluate at 1, -1, comma 0. So get U, V is -1, U is +1, 0, 0, E to W, W is 0, so get 1. V, -1 times 1, so it's just -1. Okay, so we get df, dg at the given point individually. Now, by chain rule, df composed with g, df takes g as input, multiply by dg, right? Matrix multiplication. So df is -1, -1, 1, 1, 1, -1. Then multiply by -1, 1, 0, 0, 1, -1. So we have, this is a 3 by 2 matrix. This is a 2 by 3 matrix. So when we multiply, we do dot product, the row vector with the column vector, right? So this, you see this dimension 2 will be absorbed. So in the end, we'll get a 3 by 3 matrix. Let's use blue color. So first row, we get from this row vector dot product with each column vector. Okay. -1, -1, dot product with -1, 0, get a +1. -1, -1, dot product with 1, 1, we get -2. -1, -1, dot product with 0, -1, we get a +1. Then we do the second one. 1, 1, dot product with -1, 0, get -1. Then with the second one, we get a 1, 1, we get a +2. 1, 1, 0, 1, we get -1. Then the third one, 1, -1. 1 times -1, -1, so -1. 1, -1, 1, 1, get 0. Okay, 1 is plus, 1 is minus, right? Hold on. So 1 times 1, right? 1, -1 times 1, -1, plus, add together, get 0. Then 1, -1 with 0, -1, get a +1. That's it. So 3 by 3 matrix. So it doesn't matter each method. So in the end, we should get this matrix, this 3 by 3 matrix.